This one, all right, 6.6. We are in 6.6. So 3/5 minus 1/3 equals x over 9. Okay. New section, 6.6. So we finished 6.4, 6.5. That was adding for 6.4 and subtracting for 6.5. Rationals, fractions. So now, what's different here? That kind of looks the same. We got fractions, they're subtracting. How is this any different from what we just did in 6.4 and 6.5? Got to find x, yeah, well said. Yeah, solving for x in the end, isn't it? And that also implies we have an equal sign. Notice we have an equal sign, right? If you look back in your notes, take a look for a second. None of the problems we did today had equal signs, right? In fact, look back at your notes. There were no equal signs. None of them had equal signs anywhere. No equal signs. We have an equal sign all of a sudden. Okay, great. Well, what does that mean? Well, it actually means all of my thinking is going to change. It means there's a wall, there's a left side of the wall and a right side of the wall, and all of my thinking is going to be do to the left whatever you do to the right. That's different than I've been doing for 2 hours. For 2 hours, I've been giving them what they're missing where? Top and bottom. Top and bottom. It's going to totally shift now. And the trick is they're both on the next exam. And it slaughters many of a student. This separates if you don't spend enough time on it, right? So you got to get the fundamental thing. I'm trying to reach you logically, because if you get it, it'll be a lot easier to work it out. So in math, we're always keeping a balance. There's 2 ways to do that balance: top, bottom, or left, right. How do you know which one? If you have an equal sign, then you do left, right. If you don't have an equal sign, you got to do top, bottom. All right. So let's get going. Enough with the theory. We need the LCD, don't we? Right, 5, 3, and 9 are common denominators. Are denominators, and we need a common denominator. Let's go over here. Remember the L box thing? 5, 3, 9. Put them over there. Let's find the common. Can you find the common? What do we do to find? What goes into 5, 3? What goes into a couple of them? 9. 3 does. 3 goes into 3 one time. 3 goes into 9 3 times. 3 doesn't go into 5. Bring down the 5. Good. And now multiply these guys together. 9 times 5, 45. So 45 is the LCD or LCM, whatever you want to call it, common denominator. 45 is going to be the common denominator. All right. Good so far? Just doing the same old box thing. We did that yesterday, didn't we? Yeah. Finding common numbers. Now, what am I going to do with that 45? I am not going to do top and bottom. I'm not going to do, give them what they're missing, look at your neighbors and compare thing I've been doing for the last 2 hours. What I'm going to do is I'm going to take the 45 and I'm going to put it in the top only. Right? These are 45 over 1, 45 over 1, 45 over 1. Just the top, not the top and the bottom. Just the top. And not just what's missing, but the whole LCD. Why? Am I allowed to do that? Can I do just the top? Don't I have to keep the balance with the bottom? I'm not thinking top bottom. I don't care about top bottom. What do I care about? I have an equal sign. So what do I care about? I'm not balancing the top with the bottom. When you have an equal sign, you're balancing the what with the what? The left with the right. I don't care about top bottom. It's not even in my brain. Not thinking about top bottom. I'm just thinking left, right. You get that idea? That'll be on. They'll be both on the next exam, and students get them all mixed around. Does that make sense? If you have an equal sign, it's left, right. Right? We're always keeping the balance in math. There's 2 ways to do that. If you have an equal sign, it's left, right. If you don't have an equal sign, that's when you got to do top, bottom. That was the last 2 hours. We didn't have equal signs. So I had to do the same to the top, right? I put the parentheses, top, bottom, same thing, right? But now left, right. Okay, what happens from here? That's the hitman. This is the hitman thing. Take out the denominators, right? 5 goes into 45. Use your calculator if you're not sure. 9 times. Cross them off. Multiply what's left over. 9 times 3? 27. Good so far. 3 goes into 45. 15 times. 9 goes into 45. 5 times x. 5x. Look at that. No more fractions. This is an easier section. That's the good news. This is easier. All the fractions are gone after the first step. The hitman kills them. We take them out. Does everybody see what happened there? Now we can finish easy. What's 27 minus 15? 12? Last step to get x alone? Just divide, right? By the 5. Boom. Done. 12/5. Much easier, right? Much less mess because the fractions go away after the first step. This will be a much easier section. So that makes sense. What people get into trouble is when they try to make common denominators instead of killing denominators. Let me go back and show you one more time. Right? Let's see. Well, whatever. It's the whole thing. What was the problem? It was 3/5 minus 1/3 is x. So one more time. The mistake you don't want to make is you don't want to come in here and go, oh, what I got to make. Here's the mistake. People go, oh, 45. They find here's the mistake last student. They find the LCD 45. They do the box thing. They're good at that. They get the 45. They come in and go, okay, I got to make him for what's he missing? He's missing the 5. So that'll be 5 times 9, 45. What is he missing? He needs the 9. No, none of that top bottom stuff. No, none of that top-bottom stuff. I have an equal sign here, right? I have a license. An equal sign is a license. You don't have to mess around with top-bottom. You're allowed to do left-right. When you have an equal sign, you can think left-right. You're not controlled, limited to top-bottom. We're going to do left-right. I'm not going to do any of that kind of stuff. I'm not interested in making all the denominators common, the same. I'm interested in killing the denominators, to use a dramatic word, so you'll remember it. Right? See the difference? I'm wiping them out. I'm not making them the same. That's a different kind of situation. So I'm multiplying 45, 45, 45, top, all the way across the top like that. Is that good on that? And then the rest the same. All right, let's try one of these. I like these better. Those last two sections are some of the messiest in the course we just finished. So 2/5 plus 1/2 is 1 over x. All right. So you see the equal sign. So all you're thinking is left, right. You're not going to put anything in the bottom. It's left, right, tops only. Left and right. So first thing, find the common denominator. Can you just tell what it is? Don't forget the x. He's in the denominator too. 10x, right? Yeah, don't forget the x. 10x, good job. Right, because 2 and 5 go into 10, right? And then you got to have the x also. So 10x is the common denominator. What am I going to do? Put it in the top and the bottom? No, I'm being sarcastic. No, right? No. Is everybody getting that? Everybody see the difference? I'm not. Here's what I see a lot of students do who don't get this. They come and they go, oh, okay. Multiply top and bottom by 2 so I can make that. No. We are not making same denominators anymore. We're killing them. We're not making them the same. We're wiping them out, right? Because I have an equal sign. I'm not doing top and bottom. I'm doing top only, left and right. So 10x, 10x. 10x over 1. Those 10x's are over 1, really, right? Nothing in the bottom, notice. I'm not thinking top, bottom. I have an equal sign. Right? If two things are equal, as long as you do the same to the left and the right, they'll be equal afterwards. You can multiply by 1,000,000 if you want to. You do it to both sides. If they were equal before, they'll be equal afterwards. Right?
What if you multiply by 10x instead of just 10x?
Why am I doing 10x? Because there's an x in the denominator. And that's part of the common denominator. So the common denominator has got to be a holder that holds everything in any denominator anywhere. Does that make sense? Yeah, and not only that, if I just did 10 instead of 10x, if I just did 10, you see this x would not go away. This x would not cancel. it knows I would have 10 over x, I'd still have a denominator. So I want to wipe them out. Remember, this is a hitman. He's taken out every denominator. If he fails to take out a denominator, then something's wrong. Good question. Does that make sense? Anything in the denominator has got to be part of the common denominator. So what happens now? Cancel, cross cancel, let him do his job. Let him take out every denominator, multiply what's left over. So 5 goes into 10, 2 times what's left over? 2 times x times 2, 4x. Good so far? Plus. 2 goes into 10, 5 times what's left over? 5 times x. Good? No denominators, they're gone, right? X cancels over 1. The x is canceled, don't they? Even that denominator is gone. What's left over? 1 times 10, 10. See that? Isn't that great? No more fractions. It's better to kill them than to make them common. It's true for math, probably not true in any other arena. It works here, right? All right, then we get 9x is 10. How do you get x alone? Divide by the 9. It's fine to leave the top bigger. There's our answer. 10 ninths. That good? This is an easier section. Just top, 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 not the bottom. We're not doing top, bottom. We're doing left, right. Top, top, top. Questions on that one? Not good? Want to try another one? Okay. So, let's see. 3/5 plus 7/27 equals, there's the equal sign, r over 45. So you got to do the LCD thing over here in the side. 5, 27, 45, you know. Find out what the LCD is, and whatever it is, top, top, top. So what goes into a couple of these numbers, you know? Looks like 5 does, 9 does, right? A couple layers there. So I'll do 5. 5 goes into 5 one time, 5 goes into 45 9 times. Bring down the 27 because 5 doesn't go into 27. Next layer. Ready for another layer? What goes in? 9, obviously, huh? Another layer. 9 goes into 27 3 times. 9 goes into 9 once. Bring down the 1. Is that good? Questions on that one? We're not done yet, huh? So what's the common denominator then?
135.
Yeah, you multiply 5 times 9 times 1 times 3 times 1. Is that always 135? By the way, I'll do it real quick. You could have done it the other way. You know, 5, 27, 45. You could have started with the 9. 9 goes into 27 3 times. 9 goes into 45 5 times. Bring down the 5, and then 5 goes into 5. One time, bring down the 3. That'll work too, right? 9 times 5 times 1 times 3. Doesn't matter what order you do them in. Same answer, 135. So 135 is the common denominator. So now what do we do with it? Well, we have an equal sign. So all my thinking is left, right, not top, bottom. So take that 135, put the whole thing, not just the missing part, notice. Right? This has nothing to do with getting what you're missing that your neighbor has. This has to do with wiping out neighbors. No, we wouldn't want to do that. That would be totally wrong. But I'm just saying radical things so you remember. That's all I'm doing here. So you remember, Mr. Heron is some kind of wacko talking about wiping out neighbors. It's crazy. So you remember, whatever it takes. So we're wiping out denominators, right? Not making common denominators. We're wiping them out. These are over 1. These are 135 over 1. So cross cancel and multiply what's left over. So just use calculator. 5 into 135. 27. You can tell if you look over here, because 5, 9, and 3 is what makes the 135. So if you divide by the 5, you're going to be left with 3 times 9, 27. You don't have to, you just use calculator. 27 goes in there, I can tell, because there's 27, 3, and 9, so it goes in there 5 times. 45 goes in there, I can tell, because 5 and 9 is 45, must be 3 times. So what do we got? 27 times 3, which is 81. Right, you multiply the leftovers, right? 5 times 7, which is 35. And 3 times r, which is just 3r. No more fractions. How nice. Everybody see that? Gets rid of all the fractions. Okay, and then adds a 1, was it 116? 116? Last step divided by 3. We're done. There it is. 116 thirds. Is that good? Does that make sense? I'm going to do 1 or 2 more of these. Can I move on? So common denominator, put it in the top, and then cross cancel and multiply the leftovers. You use your calculator. So let's do this one. I'm going to change to x. X plus 4 over x equals minus 5. Equal sign, left, right. So on the exam, you'll want to identify equal sign, left, right. Okay. So we're going to find the common denominator. It's going to be a hitman taking out all denominators. All right. So what is the common denominator? Just x. Huh? That's the only thing under a bar anywhere up there. That's the only denominator, huh? Is x. So the common denominator is x. Okay. So what am I going to do with it? X, x, and x all over 1. Right? Left and right. That is the common denominator. It's just x. That's the only denominator. So multiply through everybody by an x over 1. Go ahead and do the next step. Remember what you're supposed to do. He's cross cancel. Right? He's taking out denominators. Cross cancel, multiply what's left over. So x times x is x squared, right? Here x is cancel and we just get 4. Here we get minus 5x. Is that good? No more fractions. Again, that's the beauty of this section. The fractions, the denominators are canceled out. No more fractions after the first step. Okay. Well, what are we supposed to do with this? What's that? Right, because we want to get 0. Good. Does everybody remember? This is the sea monster. All said and reared its ugly head. Right? I'm trying to do weird stuff. So you'll remember. Right? Remember when x squared suddenly shows up? It's going to keep happening. See how just out of nowhere? We're just doing fractions and whoa, x squared. Right? Whenever x squared shows up, all of a sudden, x squared with an equal sign, you want to have a knee-jerk reaction, get a 0. And then the rest is, I think, will flow for you if you just remember the 0 factor, the parentheses. And step 3, each one equals 0. Remember, you just get opposite sign answers. Remember that whole thing? So, yeah, we look and we go, oh, yeah. I remember the x squared, the sea monster. We've got to get a 0. So add 5x to both sides. What do we get? X squared plus 5x plus 4 is 0. Factor, the 2 parentheses. Remember that whole thing? What multiplies, what times what is 4 and adds to be 5? Wow, 4 and 1, 1 and 4, either order, doesn't matter. Both plus, huh? 1 times 4 is 4, they add to be 5. And then, each one gets their own 0. And, it's just going to be opposite sign. You want to just jump to -1, -4 now. That is going to be the answer, right? -4 and -1. If you can read all that. So the answers are -4 and they just want both answers with a comma. Order doesn't matter. no parentheses needed. -4, -1. Right, at this point you can tell it's just opposite. Whatever's in the parentheses, it's opposite, huh? Is that good? Is that making sense on that? So we got about halfway. Well, we didn't get halfway. We only got to number 6. But we'll do more of that. We'll finish that, and word problems, and complex fractions tomorrow, and then more word problems on Monday, and then take our practice test, and Tuesday's a real test. We got a lot of work. All right, let me set you up here. 8 and 30. Boom, boom. All right, click A for Apple. A for Apple, and we are done. These 2 sections are due tomorrow. It's a big bit of work. Have a good evening. If you're having any trouble, Roberto will be available. Half an hour, LI 134. Everybody get their tests back? My old tests are there. All the old tests if you need any.
I need the last 7 questions.
What's that?
The last 7 questions that I didn't have time, so I had to yeah.
Oh, on the test?
Yeah.
Oh.
I finished the last 7 questions, and
Wow.
out of those 7, they were all wrong. So
Oh, shoot. Yeah, you'd hope you'd get 1 or 2 by guessing, huh?
yeah, but no.
Oh.
Mr. Harris, I'm just wanting to make sure this is it
Crossing
for,
off the days as we go, huh?
yes, this is it for tomorrow, right? Because I'm gonna
Yes.
be absent tomorrow, so I'm a little nervous because
You can check out the YouTubes.
yes,
Those are going to be it. Mm-hmm.
yes, I'm check out the videos. I told my partner to be on call.
Okay.
So-
Also, you can even look ahead of time. I've got the lectures up from like last spring.
Okay, yeah,
Two.
I'm halfway done with 6.6.
Good.
The
Excellent.
view examples help a lot.
Yeah, those
So,
can help. Yeah.
Okay.
Yeah,
I'm just,
but if for some reason sometimes my iPad wigs out. If those don't end up there, you could always they're up there from last semester too.
okay. I'm just worried because you said we're gonna have word problems.
Yeah, that one 6 point.
8.
Is it 8? No, 7 is word problems and 8 is complex fractions.
Oh yeah, then you said that too, and that sounds ugly. So.
Yeah, they all are.
Okay.
Yeah.
Okay. Thank you so much.
Yeah, you're doing good work.
Thanks.
how's it going?
Pretty good, Roberto. How are you doing?
Doing well.
It's a lot of 3 hours of.
I don't know how they do it.
I'm talking about me, man. I'm talking about me.
No, you have like still at 9 hours, right?
Yeah, well,
At least.
7. Back to back. No, 6, 7, 8. 3, 3, and 2. Yeah.
That's even worse. You can't do that.
Yeah. It does the second 3 hours where it's the same. You know.
I can't imagine that. I don't know how you. Props to you. I started getting dull after repeating myself again.
Yeah, it starts to lose a little bit of its punch, I think.
At least you build up consistency, right?
Yeah.
And I don't know that you're consistent in the same way you explain it here, you explain it there. Because
Right, that is certainly true. That's true, yes.
I see. So just to recap, because I always forgot, LCM, right?
Yeah.
That stands for least common multiple, and that would be the smallest number that they both go into, that the set goes into.
Yeah.
And
The
they-
smallest among the big numbers they go into. Right.
Yeah, so the smallest number that the set can go into, so whatever.
Mhm.
Okay, and then GCF would be the biggest